let's get started on this. I'll be talking about autoscaling in Kubernetes, typically autoscaling with your workloads, which is related to pods. And the other dimension to it is autoscaling for your cluster, right? So a few ground rules, maybe if you want to interject, and if I can answer it within, if I have a direct answer, I'll go ahead with that. If not, we'll take it in the breakout session and then we can connect more, right? So let's get started. I have a small demo in between to talk about pod autoscaling as well. So yeah. So a little bit about me. I'm the Director of Engineering with InfraCloud Technologies. We typically work in the container ecosystem based out of Pune and Bangalore. Containers, DevOps, clouds, Kubernetes, everything comes under our banner. Yeah, so let's dive in. So what is autoscaling, right? And this is what we'll be covering today. What do we autoscale in terms of Kubernetes? What does it mean? What is the machinery behind autoscaling that drives it? How do you pick up metrics and what drives when you hit a certain threshold, what autoscales and how does it do that? And so to start off with, this is a very simple diagram where you have a faucet which is dripping water inside a sump or a tank. The flow of water is the rate of request that you get for an application. You could visualize it to be that way. And the tank is basically a pod or a node if you take it in context with Kubernetes, right? Now what you see here is if the water reaches a certain threshold, if it reaches the 80% mark, we don't want the water to overflow, right? So it basically falls into another bucket, and that's how autoscaling happens in this particular scenario. This is a very simplistic example. Now, there are certain metrics that drive this, right? How do you define what will autoscale? So the 80% mark is the rate of request at which it will autoscale. That is basically defined by the level of the sump that is filled. Or the other thing could be, which is related to you, which is specific for you, is the number of droplets that hit the water. The water level. If there are 1,000 droplets that hit the water level, you might want to autoscale, right? So that's a very simplistic example of what autoscaling is and what we'll be talking about today. So let's move on to two dimensions of autoscaling in terms of Kubernetes. How many of you guys understand what is a pod in Kubernetes? You do? Okay, so quite a few. So pod is a unit of deployment, right? Where you run your applications, you containerize them, and that is the workload that runs on Kubernetes. And there is an infrastructure on which the pod runs, which is your node, right? And that also needs taking care of. So the scale out scenario of autoscaling in Kubernetes is at two dimensions or at two levels. One is when you have a lot of rate of requests that hit your workload, which is your pod, you would want to scale out your pod or your workload. And if you have pods that are stuck or waiting to be scheduled because there's not enough compute at the back, you would want to scale out your cluster, right? So two dimensions to it. So that's basically the what of autoscaling in terms of Kubernetes and what we'll be dealing with. Now, why do you want to autoscale, right? So my counter question would be, you typically provisioned your cluster or you modeled your deployments in terms of certain assumptions. You said that I will have an application that runs which will cater to maybe 5,000 users today. And then you have a sale that goes on which says that, okay, there is a lot of surge of users that log into your application. And when that happens, your current forecast of whatever was the compute or whatever was your deployment model is under a lot of stress, right? So you want an automated way or a threshold that you can set which says that, okay, hey, if it hits this threshold, then I would want to scale out, right? So in typical scenarios, you would want to optimize your usage, your current usage with whatever is the actual usage, right? You do not want to over provision or under provision. And that's why you would basically take autoscaling and do it in your use case, right? So the major benefit in terms of cloud adopters is that you can optimize cost because you don't want to keep running instances and VMs which are not being used or which are being used a lot and they cannot sustain the load that is getting to your particular application, right? So that's why you would autoscale. Now, let's start with the demo, and I'll do the demo, and then we'll look at what are the machinery behind this, right? how many of you guys work with any monitoring solutions like Prometheus or Datadog or, okay, fine. So this is a simple Prometheus dashboard. I'll give you the basics behind it. It is scraping for a certain endpoint. We are looking for a mock service metrics pod that we are running on our Kubernetes cluster. And it's basically, okay, it shouldn't be 3 by 3, it should be 1 by 1. Yeah, so there's one pod that is running right now on your Kubernetes cluster. And there is a pod autoscaler called as horizontal pod autoscaler, which is also effectively looking for the requests that are coming to your pod. And here at the top, I am basically looking at a specific metric. This is a custom metric that we have set, which says that if the hit count goes beyond, say, 100 in this case, yeah, so if the target is goes beyond 100, then the HPA will kick in, the horizontal pod autoscaler, and it will spin up a bunch of pods here, right? And then we'll talk about all of these things, of how these things come in together and what is at play here, right? So having said that, it's a very basic application that we have set up. I'm just going to hit a bunch of load onto the endpoint, and it will start increasing the counter. So you see that it says total hit count is 4. Let's go back to our window, and the count keeps on increasing here, right? So at some point of time, what would happen is the threshold that we have set here is 100, right? And the HPA or the pod autoscaler will kick in, and it will realize that, hey, by the way, we cannot sustain these many number of requests because we have hit the limit, and it will scale your deployment. The deployment is essentially looking at the pods in here, and it will throttle them up, right? So while this is running, I think we can maybe skip back to the slides and talk a little bit about it. Okay. So the target that you mentioned was a specific metric in your case, which is saying 100 requests for a particular deployment, right? Now, there are two types of metrics that a pod autoscaler looks at. This metric is a business metric that I have defined, which is a very simplistic metric, but it can be anything in your case. If it is the number of messages in a messaging queue that hits beyond a certain threshold, you would want to scale out. If it's a GPU-intensive application, you would want to scale out. If it hits a certain CPU threshold, you would want to scale out, right? So the key here is the pipeline or the machinery behind it, which is reporting these metrics to the Kubernetes ecosystem, right? Or to the Kubernetes controllers in this case. So all of you might know about it, that there are pods that are running on hosts, and there is a service called as Kubelet, which essentially takes care of managing or scheduling those pods on those nodes. So there is a component called cAdvisor, which essentially takes out these CPU and resource metrics, which is CPU and memory right now. I think there's network and disk I/O as well. I'm not sure about that, but there's CPU and memory that it reports out right now. These resource metrics are basically set on your pods. If you have a deployment, a replication controller, or a replica set, you specify your pod spec. Within the pod spec, you specify resource requests for the pod, right? You give it certain CPU, you give it certain memory. And the cAdvisor kubelet essentially spits them out and sends it to a component called as metric server. If you guys know about Heapster, in version 1.7 before, there was a component called Heapster which would look at these metrics and then act on top of that. And it acted also as a sink. Basically, it would store that. Metric server in this case basically pulls the metrics from your kubelet on all of the nodes, and it's reporting on those metrics saying, hey, by the way, the CPU is this much for this pod, or the CPU is, or the memory is that much for that pod. It makes it as an API endpoint, because that's essentially the metric server exposes it as a metrics resource API. And the HPA, or the horizontal pod autoscaler in this case, which is the component which is supposed to act on that measured metric, is the guy who will do the magic of scaling up the replicas, right, of your particular pod. So let's have, yeah. So metric server in itself does not really store the metrics. There is no sync to a metric server. When I mean a sync, it does not, it's just in memory. These are APIs. There must be. Yeah, so it's reporting that how much RAM is being consumed by this pod. So it's saying how much CPU is being consumed by this pod. So the kubelet in the diagram was telling, the C advisor component within the kubelet is telling you that, okay, hey, this pod is consuming so much memory or so much RAM. And that's its job. So the guy who is supposed to act on that is the HPA, or the horizontal pod autoscaler, right? So having just given this brief overview, we'll just go back to our demo and see what happened here, right? So there were metrics that were being reported by a component. We'll come more to that. And that component was saying that, hey, there are 270 out of 100 requests that are coming out right now. So the HPA got kicked in, and it said that, hey, basically we cannot take these many requests in, and if there are more requests than 100, we'll have to scale out. I've given a max pod count as 10 here. So what it actually did is it scaled out from 1 pod to 2 pods. And this is just 3 minutes ago. So the HPA kicked in on a metric that you had specified, and it auto-scaled, right? Now this is a custom metric that I have specified. But I was earlier talking about resource metrics. Resource metrics are there by default. The only requirement for that is your pod should define resource metrics. Your pod should say, hey, I want to consume 300 MB of memory. And if it goes beyond that, scale me out. So if your pods do not specify that, the metric server doesn't report that, and the HPA doesn't do anything about it. Right? So that's a mandate that should happen. So, okay. So as I mentioned earlier, there are two types of metrics that the HPA works on. One is the resource metrics, and the other is a custom metric that you specified, right? So in our case, in the demo that I showed, we had a Prometheus server that was scraping for endpoints from these pods. And it was telling you at the /metrics endpoint saying, hey, the total hit count is this much, the total hit count is that much, the total hit count has increased by 5, 10, and stuff like that, right? Now, in case of doing the HPA for custom metrics, there is a special component or special care that needs to be taken, because Kubernetes doesn't really know, right? It's a use case by use case driven. So you have processes that is scraping for those metrics now. So the measurement is already done. Now who would act on that? Kubernetes only understands the resource metric API. The resource metric API is a standardized aggregated API that the HPA can listen to, right? So you would have to write an adapter in here. There's a Prometheus adapter that's already there. For Datadog, I am not sure if it's not there for Datadog right now. But for your monitoring solutions, if you want to do this, you'll have to look up if there's an adapter for you. Right, so the metrics were scraped. The adapter would basically just translate those metrics. It would say the total hit count was 200, and Prometheus reports it into some format. I'll just translate it and I'll expose it out to custom.metrics.k8s.io. That's the API group that it looks for. And then it will go to the aggregator, which will basically have that endpoint ready, and the HPA will kick in, which will say, hey, by the way, I was supposed to limit it to 100. Now let me kick in and let me scale out, because I have a definition that I could surge up to 10 pods. Right, so that's what happened. To tie it back, I am basically tailing for custom.metrics.k8s.io. And so that was being reported. The last count was 249, and that's essentially how the HPA here could understand, because it looked at this 249 number and then kicked in. Right, so that is about pod autoscaling, right? In the sense, how would you do pod autoscaling or your workload autoscaling based on a resource metric, or how would you do it on a custom metric that you have defined yourself, right? So we'll dig into what is node autoscaling or cluster autoscaling, and what is the machinery behind it, or when does it kick in, what sort of constraints does it adhere to, or what considerations does it have, right? Yeah, so there are two implementations of the node autoscaler right now. One is the Kubernetes cluster autoscaler or Kubernetes autoscaler as it is called. And the other is escalator, which is from Atlassian. So we'll talk more about the Kubernetes autoscaler. We'll skip escalator. I'll leave it to you guys to go back and take a look at that. But yeah. So autoscaler, similar to how pod autoscaling is, it's implemented as a controller. If you guys know about controllers in Kubernetes, deployment is a controller, replication set is a controller, a daemon set is a controller, stateful sets and stuff like that, right? So controller keeps looking at it runs as a control loop at a certain cadence, and then it keeps looking at the API, which is providing it inputs on what to act on, right? So cluster autoscaler is implemented as a controller, similar to how HPA is. Horizontal pod autoscaler controller is what it is called. When does it kick in, right? So pod autoscaling is fine. You had a bunch of requests that there was a lot of search for your workload. It got kicked in, it scaled up your pods, that's fine. Now what happens if this is, the case is inverse, where you have a lot of requests that are coming in. The HPA is throwing pods on your nodes, saying, hey, my thresholds have hit, and now I have to scale up pods, right? But your compute infrastructure underneath is not able to handle that. So you'll have a lot of pods that are in pending state because the nodes are in CPU pressure or in disk pressure or cannot handle your pod requests right now, right? So there'll be a lot of pods in pending state, and that's where the cluster autoscaler will kick in. It will see that, okay, there is workload requests, but I'm not able to fulfill these workloads. So what do? I'll scale out the underneath compute. I'll scale out the node, the cluster itself, right? That's when the cluster autoscaler kicks in. Now there's another thing where if your nodes are underutilized, it will also kick in to scale them down. But then there are certain constraints to it, right? You cannot just scale down something because it's underutilized. Maybe you still want it to be there, or it's during Christmas, everybody's on holiday and there's no workload that is running, but you still want it there, right? So there are considerations for a node autoscaler on when it downsizes it, and we'll take a look at that, right? So pod disruption budgets. Pod disruption budgets are essentially budgets that you specify saying, for my replication controller, I want at least 2 pods to be running all the time, out of 4, say maybe, right? And if you try to evict those pods, Kubernetes won't allow you to. So if pod disruption budgets are too restrictive, the node autoscaler will not downsize, because then you're losing out on the number of desired state replicas that you wanted in your cluster, right? If you have strong affinity or anti-affinity rules, for example, you have a deployment of 5 replicas, and you have mentioned that every pod that gets scheduled on a node should only be scheduled if the same type of pod is not there, right? So it is sort of spread out. So you have a 5 replica deployment and 5 nodes, or each of them get deployed on one node at the same time. If that is a restriction, cluster autoscaler will not downsize. You can run kube system pods on a particular node. It does not necessarily have to be run on the Kubernetes master. So that's a restriction, it won't. Local storage, when it comes to storage, you cannot. You'll end up losing data. And then to override all of this, there is an annotation that you can add on your controller or deployment controller or a replica set controller, which says the cluster autoscaler is safe to evict, whether the pod is safe to evict, whether it is false or true, right? And if that is the case, the pod will get downsized, the node can also get downsized later on. So this is basically safety first. These are the considerations of downsizing node autoscaler. Now pod autoscaling is fine, but clusters are not a very simple model, right? In a large organization, the model of your cluster, or in case of a multi-AZ deployment, you can have different workloads that are running in different areas or are running on different kinds of infrastructure, right? There might be GPU intensive VMs that you would have. There might be CPU intensive units that you might have. For storage, you might spin up VMs that require a lot of IOPS and stuff like that, right? So when you talk about node autoscaling, upscaling or downscaling, right? In clusters, the node autoscaler can work within a node pool. If you guys understand what is a node pool, it's basically a collection of the same kind of workloads or the same kind of infrastructure clubbed together. It's a very common topic in terms of any cloud provider, right? So it can work within a node pool where it will spin off VMs within the same node pool, or it can work across AZs so that you are covered in case of a disaster, right? So that's essentially what a node autoscaler can do. Now, HPA and the node autoscaler working hand in hand. Let's look at a particular use case that would run through. So you have a set of workloads that is running on a cluster. There's a lot of requests that come in. We'll start from the right, by the way. So the HPA scales up your pods because there are a lot of requests. Those pods end up being in pending state because your underneath infrastructure cannot cater to that. So that triggers the node autoscaler, which in turn will scale out your infrastructure at the bottom, which will in turn allow your pods to be scheduled. After a while, when the surge of requests dies down, the HPA kicks in again. It says, hey, by the way, the thresholds are all met and you guys are idle, so I'll kick you out. So it will downsize the pods. The pods have gone down. The node starts becoming underutilized. The node autoscaler kicks in again and it downsizes your particular cluster, right? So that's basically a match made in heaven. That's essentially what it is. Mind you, a node autoscaler typically is very easier to implement with any cloud provider, right? There are different challenges to deal with in a private cloud infrastructure or your own data center. But this is a typical use case where you see a lot of organizations go through, right? On when you want to implement HPA or node autoscaling, what would you have to consider, right? The scaling speed. So in the demo that we saw, essentially we had a certain threshold beyond which your pods were autoscaled. Now there is a current limit or a time gap that is present within the Kubernetes cluster, which is at the controller level, which says that any subsequent upscale or downscale will happen only after 3 minutes, right? So that is a time that you will have to tune for your particular cluster. If you keep on getting a lot of requests, the subsequent requests wait for 3 minutes for them to stabilize, and then it will kick in and scale again, right? So you'll probably have to tune that. These controls also exist for node autoscaling. The last latency test that Google did was for 30 seconds or so for a node to be scaled up. But yeah, these are all parameters that you can fine tune. So scaling metric, like I mentioned earlier, two metrics that it looks at, the resource metrics as well as the custom metric. So for each application, you will have a different metric to scale at, right? So like I mentioned, if you hit a certain threshold of number of messages that are being sent on your queue, maybe that's a metric for your application. Maybe if it's another application which says that number of HTTP requests that hit for my application scale based on that can be another metric. So the essence of the messaging here is that the scaling, there is no silver bullet. There is no nothing that says that all pods will scale up only for CPU. You'll have to make sure that your application can cater to that particular parameter that you're specifying, right? So you have to choose your scaling metric appropriately. Pardon? Disk IO also can be possible. And if it is not supported directly, you could basically do it as a custom metric then. So monitoring adapters, we were using Prometheus as your monitoring pipeline right now. Prometheus scrapes for metrics at a certain endpoint, right? So it says /metrics is where it will look for the metrics of your application. You might use Datadog or Sysdig or any other monitoring tool that you have in your particular organization. For that particular metric that is reported by your monitoring system, and for Kubernetes horizontal pod autoscaler or node autoscaler to understand that, you'll have to write an adapter. In the diagram, there was a Prometheus adapter that was translating the metrics that are spit out by your monitoring pipeline to the custom metrics API endpoint, which is understood by the HPA, right? So you have to make sure that you either have the adapter there. If not, then you'll have to build one yourself. So that's another consideration. Stateful sets is a very tricky topic. When you want to scale up or scale down a stateful set, right? You have to ensure that, okay, so this typically works very easily with applications that are cluster aware, say Cassandra or Kafka, which have replication built in themselves, or they are cluster aware by themselves, right? So if you want to scale down a MySQL or a Postgres pod up or down, right? So you'd have to take special conditions, whether the data is there, whether there's replication that has happened, are you protecting yourself from disruptive operations or not? So be cognizant of that fact of what you are scaling up and scaling down, and take care of that, right? So yeah, you can basically take a look at the metric server, or the demo that I showed is in a GitHub repository, and if you would want, you can tinker around and play with that. But that's about it that I had.